Okay then, today we're talking about chemistry, like real chemistry for the first time. And this is going to be filling in pages 5 and 6 on our packet. Let's see if I can get those pages to pop up here. There we go. These are the sections that we're going to be filling in today, everything from the bottom of page 5 through the end of page 6 and filling in that periodic table there. So let's get to it. Well, if we're going to talk about chemistry, let's define it. Chemistry is the study of matter and the changes that it undergoes. So we're going to start, as you can see, by defining what is matter, and we're going to talk about the different types of matter, and then we'll get into those fun changes that matter undergoes. Now, FYI, not all of the changes really are that fun or exciting. Some of them are rather boring, but we've got to study all of them. All of chemistry isn't always explosions and fire and dramatic stuff. Sometimes it's the boring stuff, but it all connects and helps us get to that fun stuff. So, studying matter and how it changes. Well, what is matter? Matter is anything that has mass and takes up space. Well, that's easy. We need to have mass and we need to have space. And it's not either or. You need to have both of those things. And they need to be measurable and provable quantities for that thing to be matter. So, my first kind of challenge to you is, air matter? How could you prove that air is matter? You'd have to bring it back and prove to me that it both has mass and takes up space. So, might be a little bit challenging, but think on it. Come up with some kind of answer or idea for me. Another challenge is, what kind of things aren't matter? What kind of things don't have mass or don't take up space? Doesn't everything take up space? So think on it, because chemistry doesn't actually study everything, just the things that have mass and take up space. So, work on it. We'll talk about it in class next time. So, if we're going to dig into matter has to have mass, we need to understand what mass is, and especially how it's the same and different from weight. Because oftentimes in society today, these are used interchangeably, but as a chemist and as a chemistry student, they are distinctly different quantities. Mass measures the amount of matter in an object, what stuff is physically inside of you. Fun fact, there's an average of 100 trillion atoms in every single human cell, and I'm not exactly sure how many millions or trillions or quadrillions of atoms are in each human body, but it's a lot. So you got a lot of matter in you, for that matter. And then weight, on the other hand, measures the gravitational force exerted on an object. That means how hard is the kind of planet that you're on pulling on you? How heavy do you feel? And I have a little physics equation here showing you that weight is equal to mass times the force of gravity of any specific planet. So weight does have to do with mass, but mass and weight aren't the same thing. We've got this other gravity factor in there. Also gave you a few of the gravitational constants of the Earth and Mars and, other planets in the solar system, just for your information. Play around with those ideas. So those really are the fundamental definitions that we need to be able to talk about chemistry. There's one more question at the bottom of the page asking you how mass and weight are different. And the best way for me that I've found to kind of compare the two is to compare what you need to do in order to change them. So in order to change mass, you have to change the matter, the atoms, the stuff inside you that you're made up of. And in order to change weight, you could simply change gravity. Sorry for the lag on the image there. So you can see Bart Simpson here trying to change his mass by adding some more atoms into his body, and some laboratory student that definitely removed some atoms from his body. That mass has changed, and technically their weight has changed as well. But in order to change weight, all we'd have to do is change gravity. We wouldn't have to change ourselves. We wouldn't have to change our mass and our atoms. So, put that in your own words or come up with another way to answer that question and explain how these two things are different. And then we're ready to flip the page and get on to page 6. At the top of page 6, it introduces Chemical elements. Finally, we're going to be dealing with elements and the periodic table of elements. And so first, let's go over how the periodic table is organized. It's got groups and periods. Groups, also known as families, are the vertical columns of elements on the periodic table. And these vertical columns are special and important because they have similar properties. They share a whole lot of common features and characteristics, and they're generally going to have their own special name for that special column of elements. Periods, on the other hand, as you might have guessed, are the horizontal rows of elements, and unfortunately for them, they're not really that special. They don't really have much in common, not much going for them. So they're there. They do help organize the periodic table, but we're not going to pay a whole lot of attention to them. So we're going to start by talking about some of these special groups and some of their properties that they have in common. There's a fair bit of writing to do in this section, but this is basically it. So our first special group of elements is actually not a specific group on the periodic table. It's not a vertical column. We're going to talk about metals as a whole. Metals are their own kind of group. It's a group of groups almost. And the properties that they tend to have is that they're good conductors of both heat and electricity. They're malleable, meaning it's bendable, lustrous, shiny, ductile, it can be pulled into wire really easily. And in general, they tend to be solids at room temperature. Little mercury has to ruin it for everyone. Mercury, if you didn't know, Hg on the periodic table, is a liquid at room temperature. If you didn't know that, or if you've never seen mercury, let me know. I have a little sample of it in the classroom I can let you look at. But our metals share those properties. And then there's a few special metal groups that we're going to talk about specifically. Group 1, the first column on the periodic table, are what we call the alkali metals. And it's that entire first column except for hydrogen. And you'll get your own periodic table next class period, and you'll see hydrogen's at the top. And for some reason it's over there, but it's not actually a metal, and so it's not an alkali metal. Now, the one thing that you should know about our alkali metals is that they are very, very reactive. These are the elements that react with water. And so if you do have one of them in a fire or something, you need to know that so that, you don't spray water all over them, because that's not going to make things better. Now, Group 2 is going to sound a lot like Group 1, but Group 2 are the alkaline earth metals. Notice, Group 1 are metals, and Group 2 are metals as well. Group 1 has one name for these special metals, and Group 2 has two names. People get those confused a lot. They sound a lot the same, they look a lot the same, but Group 1 has the shorter name, Group 2 has the longer name. Groups 3 through 12 are called the transition metals. They're kind of in the middle between our metals and our non-metals. So they're transitioning towards being non-metals. They have a lot of weird, interesting properties there. And then that's really it for metals for now. Our non-metals are going to be substances that don't conduct heat and electricity very well. They can be solids, or liquids, or gases at room temperature. They don't really have any definite shared properties. There's a lot of differences in these non-metals, and we'll talk about why later on in this semester. But they are still their own special kind of area, and in that area we have two special groups of non-metals. Group 17 are the halogens, and Group 18 are the noble gases. Now, oftentimes we will just leave things split up as metals and non-metals, but there are technically metalloids on the periodic table as well. Metalloids are kind of half and half. Ooh, I forgot to mention, noble gases are special because they're inert and non-reactive. We'll talk a whole lot more about those properties later on, just introducing these names for right now. Back to metalloids. Metalloids have kind of blended properties of both metals and non-metals. They have a side that touches the stair step on the periodic table, and we'll see that and label those in a bit. But they are all solid at room temperature, so that's a lot like metals. And they are semiconductors of electricity And you've probably heard that word in reference to computers, which means that they do conduct electricity, although they have some weird special properties about how they conduct electricity. But they're a lot lighter than most metals. They tend to have some properties that are a lot like the non-metals, some crystalline structure, etc. So they are very special, and we'll study them a little bit, but oftentimes we'll kind of leave them out because they are kind of just weird. So yeah, that's all the writing that we've got to do for right now. I want to make a quick little note about periodic table and elements real quick. We are going to have some element quizzes. I know it's probably your worst nightmare having to memorize things off the periodic table. We'll talk about it more in class, but as you start to experiment with the names and the elements on the periodic table, I want to point out that every single element's symbol has one capital letter at the beginning and might have a lowercase letter that follows it. It might just be that one capital letter, or it could be an uppercase and a lowercase, but it is never going to be two uppercase or two lowercase. So if you see these two examples that are in your packet, that first CO over here is cobalt. This second CO is carbon monoxide. Notice, one capital, one element, just cobalt. Over here, two capitals means that there are two separate elements here, and that means that if they're written together like that, that's a compound. It's a completely different thing. You can't do this. Over here, Fe is iron. That's perfectly acceptable. Fe, I'm not quite sure what that's talking about. I guess it must be fluorine, and then there isn't just an E on the periodic table, so I have no idea what's happening there. That's not iron for sure, but I don't know what it is. So you're going to have to be careful about it, and you need to start being careful now and not just try and get better about it once you get closer to taking our element quizzes. But it's important. Pay attention to it. There's also some special elements you'll hear about called diatomic elements. There's 7 of them. I'll point them out, and we're going to keep it coming. But these are kind of interesting elements that can't go anywhere on their own. They're never going to see just hydrogen floating around as a single H atom, or a single H atom over here. If there's a single H atom ever, it's going to go ahead and grab on and bond to another H atom. They cannot go anywhere by themselves. It's kind of like those girls that can't go to the bathroom by themselves. They have to bring a buddy into the lunch line, and to get water and to do everything, they have to have a buddy. Well, that's what these elements do. Now, we're basically done. Like I said, we're done with the majority of our writing, but we are going to take a second to kind of color code this periodic table. Now, I already color coded the names that I had, but if you're going to do this on your own at home, we only need like 6 different colors, and if you make a little mark next to each of these names, then you'll be able to match the name to the color when you put it on the periodic table. So make sure that you're systematic about it, because the colors on the periodic table mean nothing unless you match that color back to the words and the names that you have. So, alkali metals, group 1. Actually, we're going to start with a stair step. I mentioned it before. It's going to be over here at the far side of the periodic table. If you see that kind of block there, just start underneath that first element and just keep going down and over, down and over. It doesn't have to be perfectly beautiful. You'll see mine isn't perfectly straight, but it goes over one block and down. That's all we need, is to get that stair step in there. Now, let's take a second to label our metals and our non-metals. Metals are going to be at the left of the staircase. Non-metals are at the right. And then metalloids as well. Now, I'm going to use metalloids. I'm going to label them with a star in every single one. And remember, we said metalloids are some element that has a side on that stair step that we've already drawn in there. So every single square that is touching that stair step has at least one side along it. I'm going to put a pink star in that space. The only one that I'm leaving off is one of the top ones there, and that's actually aluminum. It is technically touching that stair step, but I think we all know aluminum is a metal. And it does have some properties of nonmetals, but it is like 99% metal and 1% nonmetal. So we just regard it as a metal. So those are our big categories. Now let's get those groups in. Group 1, alkali metals, first column. Alkaline earth metals, second column. Notice in that group 1 I did not include the first box because hydrogen is not an alkali metal. Our transition metals are columns 3 through 12. Group 17 is all the way over here, almost at the end. Those are our halogens. Group 18 is our noble gases. And it looks like that's it, but I wanted to also point out our inner transition metals is this little block below the periodic table. And they actually do belong in the periodic table. If you wanted to see what that looked like, I have a picture for you right here. Notice they just get inserted in between the the orange and the yellow groups there, as we just break them apart and squeeze that middle section in. And the only reason why we normally see our periodic table like this instead of like this is because it fits so much nicer on a piece of paper. Plus, those inner transition metals down there at the bottom aren't used for a lot, so why would we make them front and center in our periodic table when it's just inconvenient? They just get in the way. So we just pull those out and shove them down to the bottom so we can focus on the part of the periodic table that we need. So, I hope that you learned something and you're excited to get started with chemistry. Make sure that you've labeled your periodic table carefully. That's going to be one of the big things that gets you your stamp when you come back to class. And I'll see you tomorrow. Have a good night.